30 days. That's all it takes. If Taiwan's chip factories stop, the world doesn't break dramatically. It stops suddenly. Cars don't ship. Critical systems don't update. Hospitals wait. No dramatic events, no warnings. Just silence. And a technology most people never see. Every modern system begins the same way. With a chip. Not a gadget, not an app. A fragment of engineered matter, smaller than a fingernail, etched with patterns so precise they're measured in atoms. This chip doesn't just run machines, it decides whether machines exist at all. A car without fuel is useless, a car without chips is imaginary, no steering systems, no braking control, no sensors to tell the car where it is or what's in front of it, and cars are only the obvious example. Behind every payment terminal, every satellite, every power grid controller, every MRI scanner, there is silicon, silent, uncelebrated, unseen. Most people don't think about chips because they've never had to. They've always been there. Cheap, reliable, on time, until recently. When factories shut down during a global shutdown period, the world got a glimpse. Showrooms emptied, electronics delayed. Production lines stalled for months because of something no one could see. That wasn't a real disruption, that was a preview. Because the real story isn't about chips, it's about where they come from. Look at a smartphone, designed in California, assembled in China or Vietnam, sold everywhere. But the most important part? The brain comes from a single place, a small island, 100 miles from mainland China. An island most people can't find on a map, Taiwan. Taiwan didn't start as a technology superpower. It wasn't rich. It wasn't large. It wasn't loud. For decades, Taiwan made a quiet bet, not on oil, not on heavy industries, not on raw materials, on manufacturing perfection. While other countries chased brands and breakthroughs, Taiwan chased something more boring, more dangerous: process. How do you produce something impossibly complex, again and again, without mistakes? How do you shrink transistors year after year without breaking physics? How do you manufacture at scales where a single speck of dust can destroy millions of dollars? Taiwan answered those questions while the world wasn't watching, and slowly, almost invisibly, global industry reorganized itself around that answer. Companies stopped building their own chip factories. It was too expensive, too risky, too slow. Instead, they outsourced. Design in one country, manufacturing in Taiwan. At first, it seemed efficient, rational, temporary. But over time, something dangerous happened. Concentration. More advanced chips moved to fewer factories. Fewer factories moved to fewer locations. And the most advanced of them all, those factories, ended up clustered on one island, an island with earthquakes, typhoons, and a complex geopolitical position. This wasn't planned as a global choke point. It became one. Today, the most advanced chips on Earth, the kind that power artificial intelligence, national security systems, and next-generation infrastructure, are made almost entirely in Taiwan. Not because Taiwan is cheaper, not because it's easier, because no one else can do it at the same scale, at the same yield, at the same precision. For decades, this system worked because it was invisible. Chips flowed, products shipped, consumers upgraded, The world never had to think about where the silicon came from until geopolitics entered the clean room. Because Taiwan is not just a manufacturing hub, it sits at the fault line of global power, positioned next to a major power, supported by another major global power, dependent on global trade. Every advanced economy relies on Taiwan's output. Every advanced security program depends on it. Every AI roadmap assumes it continues, uninterrupted. And yet, the system has no redundancy, no backup island, no emergency switch. If Taiwan's most advanced fabs stop, even temporarily, the shock doesn't hit one sector, it cascades. First, inventory buffers drain, weeks, not months. Then production lines pause, automotive, consumer electronics, industrial equipment, then critical systems feel it. High-tech contractors waiting on processors, medical equipment stuck in certification limbo, telecom infrastructure unable to expand or repair, all without a dramatic event. This is what makes chips different from oil, different from food, different from energy. You can stockpile oil, you can reroute grain, you can burn alternative fuels. You cannot quickly replace advanced semiconductor manufacturing. Building a leading-edge chip factory takes years, tens of billions of dollars, a workforce trained through decades of failure. You can't surge this industry, you can't improvise it. And that's the hidden system, a world that looks diversified on the surface, but underneath depends on an island smaller than many global cities. Most people assume global power is enforced with traditional hard power, but the modern world runs on supply chains, and the most fragile supply chain of all is etched in silicon. Right now, this system is running, barely noticed, barely questioned. Ships leave Taiwanese ports every day. Air cargo lifts off, carrying silicon wafers worth more than gold by weight. Inside sterile clean rooms, machines carve circuits smaller than viruses. Robots move in silence. Engineers watch numbers measured in fractions of a percent. The rhythm feels permanent, predictable, stable, essential. But nothing about this system is guaranteed, because it depends on stability, geography, politics, trade relationships, infrastructure. An island positioned at the center of global supply chains, connected to every major economy, relied upon by industries that power modern life. The world didn't plan for this level of concentration, it evolved into it. One efficiency decision at a time, one factory relocated, one cost-saving measure repeated globally until alternatives became distant and dependency became normal. The system still hums, for now. But in a world built on precision timing, even a temporary interruption can ripple far beyond expectations. And if that interruption lasts long enough, it doesn't just delay products, it tests resilience. If you want to understand how a 30-day disruption could move from manufacturing floors to global markets, subscribe to Silicon Power. Because the forces shaping the modern world are often the ones we never see.